I would like to present to you the materials referring to reciprocating engines. As we yesterday noticed, large boats require more power and only electrical propulsion is not sufficient. We need to also consider reciprocating engines, which nowadays are efficient and can meet many requirements for pollutions. The reciprocating engines can cooperate with electric systems, and we can distinguish several types of operation. The engines can operate directly with the electric generator within the genset, and next provide electrical power to electric motor, which next can provide can provide propulsion to the propeller. The electric motor can be also supplied from other source like a battery and also fuel cells or other possible sources. And another possible way is that the reciprocating engine drive parallel with electric motor the propeller with using of gearbox. The engine is also connected with generator, which can provide electrical power to the battery, charge the battery, and the power can be used when suitable by electric motor. Another possibility is to use electric motor drive the turbine and power by batteries. And in the event of discharge, they are powered by generating set. The worst scenario is when we have only a reciprocating engine, then efficiency of the system is lower, and we have a higher emission. It's not recommended nowadays. As yesterday, I would like to remind some advantages of the hybrid system. It can have a higher efficiency, lower emission. We can have a different configuration, and what can be also important, we can have also another sources from additional supply. The sources can be renewable. And one additional advantage is that we can have a redundancy in this system. It means if one engine or genset is fault, we have another genset and we can use it. We can also have a spare emergency genset, which can be also used for occasional situations. The reciprocating engines can be divided due to the principle of operation. Marine reciprocating engines can be divided into spark ignition and compression ignition engines. Spark ignition engines operate in Otto or Atkinson cycles, while compression ignition engines operate in diesel cycle. As a result, they differ in a type of fuel, gas or oil, and constructional details. For example, spark ignition engines contain a high voltage spark plug that produces a spark that ignites the fuel mixture. In addition, there are various degrees of fuel compression. On below picture we can see the strokes for reciprocating engines. we see starting position and inlet and outlet valve. There are suction stroke, and when the fuel and with air is provided to the cylinder, we have next there is a compression stroke when the piston causes pressure. Next, during the pressure, a spark plug provides spark, and there is explosion. Then we have power, and there is a work stroke. Finally, there is exhaust stroke when the gases move through the exhaust valve. Reciprocating engines can have different parameters and can be supplied by various fuels. Can be LNG or CNG, can be supplied by petroleum or biodiesel. Other fuels are also possible. Engine powers can be very different, starting from 10 kilowatts, and one unit can have above around 15 megawatts, which is quite large amount. Efficiency of the engine can be above 40%, which is not bad. Other portion of power is produced as a heat. So if we can use this heat, it's good. Other way, we lost it. Then reciprocating engines have a different number of cylinders, starting from several and to 16 or even more. The important parameter of the engine is cylinder positioning. It can be straight, or for more power engine can be V-angle. On the below picture we can see a V-angle engine. It means that cylinders are moved and there is a kind of V shape between them. Speed of the engine can be varies from 500 to 5,000. Also, compression ratio and work cycle can be different. The type of the cooling can be water or air, and the engines can meet current emissions standard. The reciprocating engines are built from many parts. The most important part is piston, made of steel or aluminum, which is located in the cylinder. Another important part is crankshaft, which is responsible to transfer power from pistons to the output. And another important part is camshaft. It's responsible to control work of all pistons in the cylinders. There are also other parts, a connecting rod between crankshaft and piston. There is a spark plug and what I'm calling jacket, which is responsible for cooling of the cylinder, which is the heatest point in the engine. Please note that the crankshaft has a complex shape, and it requires advanced manufacturing methods as well as camshaft. Both elements are very important, and it is important to to have a good quality of this element, and the tolerances are very important, and need to withstand all mechanical stresses. Another component is cylinder liners. We can have two types, dry and wet type. Wet type is cooled by the water. We can also see a crankshaft case, also known as engine body, main element of the engine. And there are cylinder head 2 or 4 wells located in each cylinder. On the right side we can see 4 well cylinder head. And the engine requires additional parts, external parts, to improve their operation and to provide the better performance. Turbocharger, visible on this right side, allows to provide more power and improves the efficiency of the reciprocating engines. There is also intercooler, which also can improve the process of the engine, or of the heat and the cycle, providing cooled water, cool air to the cylinder, improving significantly efficiency and reducing emission the same way. There are also gears, oil pump, oil filter, cooling water pump, can be powered by electric motor, or in higher power engines there may be two cooling water pumps. There is also coupling to the generator, air filter, vibration damper, spring insulators. Engine needs to be equipped with control elements. The gas dosing valve is needed to control the gas flow in gas engines, and it's linked to the exhaust gas cleaning system to control the quality of the mixture. And we can see this element on the left downside. There is also throttle valve, which can be integrated or cooperates with the drive through a set of control routes. And another element is compressor bypass valve, which can also be controlled to provide the best performance. This engine needs to have a various system cooperating together. It's needed to provide lubrication with the oil to decrease the friction, and improve cooling, and also provide other advantages. I will tell more in next pages about each system. There is also control system and exhaust, gas supply system, auxiliary supply system, cooling and heat exchange system, and crankcase blowing system. It's needed to control the emission and control operation of whole engine. In this diagram we can see the engine, generator. We can also see cooperating parts as a turbocharger, controlling throttle valve, bypass valve, gas dosing valve. We can also see engine control system, and generator circuit breaker. The task of the control system is to control the speed and power of the engine, with simultaneously control the exhaust emission, carbon and nitrogen oxides, and non-methane hydrocarbons. Reciprocating engines needs to meet gas emissions limits, and the emission can be controlled by a suitable high ratio lean mixer, and which the factor which ensures that the requirements for pollutant emission are met. We can see in this diagram the requirements for different stages, and the emission cake are much smaller for the last stage required by the European Union comparing to the previous stages. The emissions can control refers to PM, particulate matters contains in the exhaust, as well as hydrocarbons and nitrogen in the exhaust. On the right side, we can see various requirements, European Union and United States, for PM emission and NOx emission for kilowatt hours, and they are much nowadays exhaust gases are much cleaner. As already mentioned, the engine requires oil lubrication system. The task of engine lubrication system to reduce friction, improve cooling, and clean parts under mechanical and thermal load, such as crankshaft and camshaft, pistons, cylinder liners, gears, bearings, and turbocharger. In addition, lubrication seals the combustion chamber, soundproofing, and protection against corrosion. The main elements of the lubrication system are pump, filter, and oil pressure sensor. Another system which is required is cooling and heat exchange system. The task of cooling system is to ensure an appropriate operating temperature between 9 and 100 degrees. Too high and too low temperature can damage engine components, especially piston and cylinder. The cooling system consists of an engine block with cooling channels. So so-called water jacket. You can see it on the right picture. A water pump and thermostat and heater, heat exchanger, an expansion tank, and a temperature sensor. So this whole system needs to keep the proper temperature of the hottest cylinder within proper temperature ranges. It's also important to apply a good quality marine engine oil. The oil need to meet many requirements, need to be alkaline, need to provide protection of pistons and cylinders against acid corrosion. Oxidation resistance also is needed. Oil is in contact with air. The oil need to have cleaning properties to maintain metal surfaces of piston and cylinders. Need to have high flash points. Viscosity to ensure lubrication between working pans under load. and also need to have a good thermal conductivity. Another requirement is low hydroscopicity for water separation, and low, and most important for us, is low toxicity to the aquatic environment. For example, we can have a oil with following parameters. It is mineral oil with sufficient values. It is also important to note that oil samples are tested every 3 months for the purpose of checking the parameters, determining the degree of engine wear. Another fuel and gases we need to provide is a mixture of gas and air is required to burn the fuel in the cylinders. In this process, gas is the source of energy and air is the source of oxygen. Gas parameters are determined by the methane number, the equivalent of the octane number for gasoline, which is an indicator of resistance to knock-in combustion, and by calorific value. It is required to use water, clean cooling water with integrants against freezing, example glycol, and some integrants before corrosion. In this slide, in this figure, we can see the proper value, range value of the glycol in the cooling water. The engine requires auxiliary electrical equipment of the engine. We need the engine need to have a power supply panel for engine electrical equipment with protection and control elements for the engine and generator, power supplies for control, measurement and protection devices, spark plugs, high voltage with control and power supply system, starter or compressor, electric or pressure starting way of is possible. Heaters for heating water need to heat the oil before start. It's not possible to start cool engine because of possible damage. The water pump needs to provide flow of the water. Engine can have one or two water pump depending on engine power. And it can be also needed to use a small power diesel generator for starting to provide starting power. We can also have a rectifier and battery and fans. Another important element can be used is a vibration damper. The large engine have a large vibrations, and especially the shaft vibrates. And to improve and decrease the vibrations, it's possible to apply torsional vibration damper, and then the natural frequency of the shaft and whole engine can be controlled, avoiding significant damage of the mechanical structure, especially bearings and other moving parts can suffer. Also, whole propulsion system need to be well designed and protected against vibrations. Ship is can be exposure on vibration and cause cracks in structures. Places where mechanical stresses can be placed are welds and bolted connections. They are at high risk. This effect may be also aggravated by fluctuating temperatures or weakening of the structure due to corrosion. Correctness of the construction, workmanship, and assembly corrosion protection and maintenance play an important role. In addition to corrosion, high humidity and salinity may pose a risk of short circuit in electrical and electronic devices. This is prevented, for example, by ensuring tightness determined by IP level. Reliability of the engines is important because many elements cooperate together and for good operation the engine can meet expectations. But if one element is weak, then the fault is possible. So the reliability of the engine can be described by parameters, following parameters: mean time between failures, failure rate, working time until major renovation, number of renovations, service life. So the engine can be also investigated continuously to improve its life and reliability. Engine protection system is needed to control operation online and check the failures and if needed switch off the unit to prevent a significant damage. And maintenance of reciprocating engines is also required. It is needed to fill the losses of operating fluids. The operator needs to check messages from protection system. It's needed to provide assessment of the engine condition by examining the chemical composition of exhaust gases and pollutant in the oil. The maintenance also needs replacing air filters, inserts, oil and oil filter change, replacing air filter inserts, replacing spark plugs, replace gas fuel filter. Similar like cars, but the range is more important. The engine generator and generator can have a common interface. We can see all main parameters at the interface. The visualization can help control and see the operation of the genset. The operator can start or stop unit, can also decrease the power or increase depending on the situation. In this page we can see the hybrid plug-in ferry with batteries 5 megavolt amperes and with the weight of 65 tons, which provides a power for 1 hour, and the charging time of the battery is also one hour. The ferry is equipped with 4 diesel engines, B12 cylinder design, and the total power of the engine is near to 13 megawatts. Thank you a lot for attention.